it's never 0, but it's infinity.
As it approaches 0 from the right-hand side. Yep.
0 times infinity?
All right, so that was just kind of information about the natural log function, just to whet your appetite, help your understanding. Now we're going to do the calculus portion of today. And so we're going to define this now. The integral of 1 over u du is the natural log of the absolute value of u. So notice u has to be positive, otherwise it's not going to be working, right?
You've already done that.
Yeah. Now the other way to write this is just u prime over u. And this is the log rule for integration. Okay, so we now have a way to find integrals of functions that are non-logarithmic using the natural log function. Okay, so some things that we would have had to use the trapezoidal rule or Simpson rule for, we don't have to anymore. Okay, so it's very exciting for us.
Can you do that for any function?
Mm-hmm. Okay, so notice this one we can't use the power rule, right? Because it's x to the negative 1, and so it wouldn't work. So we would have had to, last chapter, use the Simpson's rule to be able to find this. And that's annoying. This is going to be much faster, right?
It's just more methods to find the better.
Mm-hmm. So right here, we could rewrite this. Because we know the factor of 2 can come out, a constant factor. And so now we have 2 times the natural log of the absolute value of x plus c.
So the whole point is to make it a whole 1 over x? Yes. Okay.
How come what?
Because the natural log is
Right, and u in this case is x, and then the derivative of x is 1, and 1 is right up there. So
1 over x turns into...
Like u is 1 over x, u is x.
U is x.
So
See how it's 1 over u?
Oh, okay.
Natural log of x turns into 1 over x. Yeah. And just back and forth.
Yeah, because it's 1, so it doesn't matter. Okay, let's try another one. So what we want to do here is really recognize the quotient forms of the log rule. Basically, we need to recognize if this is in the form u prime over u. Okay, that's what we're looking for. So if we let u equal x cubed plus x, what is u prime? 3x squared plus 1. So is this in the form u prime over u?
Yes.
Yes. So very simply, we can write natural log of the absolute value of x cubed plus x plus c. Do you see that the numerator is u prime? Do you see that the denominator is u?
Oh my god.
And if we look over here, isn't u prime over u, natural log of u?
And that's the antiderivative, is that right there?
That's right there.
Wow. And too bad only like 2% of the problem.
Will be the quotient form. Now let's try the next one. So always check that first. Let u be the denominator, so u equals tan x. And what is u prime? Secant squared x. So do you see this is u prime over u? So the antiderivative is?
So it's just tan x, it's just ln absolute value tan x plus c.
There we go.
For calculators, you don't have the absolute value thing.
It has it on it, they show you.
Yeah, it's all very small. Just focus something on the present.
We're not worried about it right now.
Yeah.
Okay. How about our next one? So u is
Times by 1/2.
x squared plus 2x. U prime is 2x plus 2. Okay, now notice that's very close to x plus 1.
So you say 1.
Or by 1/2.
So what we're going to do is rewrite this. Yeah, and you guys are already on top of this.
Yeah, we know what we're doing.
Everybody see that there? So you multiply by 2 on the numerator, so you have to divide by, or multiply by half on the outside.
So can you just skip that step and go straight to the other one? Alright.
So yeah, the answer is 1/2 ln absolute value x squared plus 2x plus c.
So if we just go straight to that and we can see that, that's fine.
Too many vertical
go.
Yeah,
lines in
mine.
there.
There are a lot of vertical lines. Some people write ln with a cursive L.
I might do that.
So if we just go straight to that last part, you know why?
If you can see it.
We see it right away. We
Yep.
can see it right there.
So like on D, you see it right away. du is 3.
So it's just 1/3.
Exactly. So since this is 3, we're going to multiply by 3 on top, meaning 1/3 on the outside.
Third ln absolute value 3x plus 2 plus 6.
Okay. Okay. So try letter A on your own here. What would it turn out to be? Yeah, -1. That would be good. Okay. Now for our next one here. What are we going to do? What we're going to do here is we're going to actually let u equal x plus 1. Okay? And so what does u prime equal? Okay, 1. And it's really 1 dx, right? Okay. So what we need to do now is actually solve for x. Because notice we have 2x on top, but that's not part of our derivative. So we need to write x in terms of u. So x equals u minus 1. Okay, so we really have the integral of 2 times u minus 1 over u squared. No, because notice u prime is just 1. So we didn't need to multiply by anything. 2 is a constant. We're going to end up taking that out, right? So what we want to do here is take out our 2, because that's our constant factor, and then rewrite this u minus 1 over u squared as 2 fractions. U over u squared, and then minus 1 over u squared.
Can you get it though? Because the one that's coming in.
What's that? Yeah, so u over u squared minus 1 over u squared. That's going to be important because when we look at this now, we have some simplification that can happen, right? U over u squared? Isn't that just 1 over u?
yeah.
Okay. And then the next one here. We're going to rewrite as u to the negative 2. Because we can use the power rule. Is everyone okay so far? Okay, and that little 2 on the outside is going to hang out there. Okay, so what's the integral of 1 over u du? ln u.
Whatever you, it's just.
Okay, we're going to add the plus c at the very end because we don't need to add 2 constants. They'll just combine to make 1 constant. And then how about this one, u to the negative 2?
I don't know.
What? Use the power rule.
2, it's just absolute value of the fields. 2
I don't know.
ln.
It's going to be u to the negative 1 over negative 1. Power rule. ln is only when you can't power rule it, when n is negative 1. If it's anything else, just use the power rule.
Plus C.
And then plus c. Okay. So now we just simplify this to ln of the absolute value of u.
That's a simple value.
And then this is going to be
Plus 2 over u.
2 over u plus c.
It's the same thing.
And then
But this is
we have to plug, substitute for u.
Well, we can solve it.
We're just going to substitute.
Or we could,
So we remember u was x plus 1. And there we have it. That is intense. All right. And a
that's crazy.
couple more examples here.
You didn't know long division better.
Our next example is going to show us how we can use long division before integrating. So if you remember on our last example, we had multiple fractions, and then we could integrate each fraction separately. So that's really what we're going to do using long division, is we're going to break this up into separate terms. Okay? So long division, hopefully, is not too far from your mind. We're going to rewrite this. X squared plus x plus 1 divided by x squared plus 1. And you just have to say, well, how many times does x squared go into x squared? That's once. And then you multiply 1 times x squared plus 1. And you get x squared plus 1. Okay. Then what we need to do is subtract here. And so I change my signs. I always like to circle it when I change my signs. So here we have x squared minus x squared is 0. We have x minus 1 and a plus 1. So we really have here x plus 0, right?
It's minus 1 plus 1. There's a 1 on there.
See the 1 here? Minus 1? Because you're subtracting from this whole function. So really we could have just written the minus 1, line it up with the correct terms, with the like terms. So now, how many times does x squared go into x? 0, right? And so what we do here is we just take our 1 plus x over x squared plus 1. So once you're left with something
Oh, yeah. Okay.
that the x squared plus 1 doesn't go into, you just write it as a fraction. So now we rewrite our integral. And it's going to be 1 plus x over x squared plus 1.
1/3.
And so we know that this is two separate things here. 1 dx. Okay. So we know the integral of 1 is x. Okay. Now, in this next one right here, we see the denominator is x squared plus 1. So the derivative of the denominator is 2x. So we need to add or multiply 2 on top and a 1/2 on the outside. So now it's 1/2 ln absolute value of x squared plus 1 plus c. Now, this is kind of technical, but can the function x squared plus 1 ever be negative? No. So we can just rewrite this. Okay. So when possible, you can drop those absolute value signs.
Wait, how come this was how come this was a log problem? Why couldn't we just derive it, like, where was the 1 over x part of this?
I don't know when to use natural log and when to just use the heading of log.
Well, that's for differentiation, first off, not integration. And so the power rule is not going to work here because you'd have to make this to the -1, move it to the top, and there's no way to work with
This
it.
makes it a lot easier.
Yes, makes it possible, actually. So like I would have never given you this problem prior to knowing the log rule. All right. One other thing is to be able to evaluate a definite integral. Okay, so now it's the definite interval from 0 to 3 of x over x squared plus 1. Okay, so you can probably see here that we need to multiply the top by what? 2. And then the outside by 1/2. And now we have 1/2 natural log of x squared plus 1. And notice we don't need to use absolute value because it's x squared plus 1. And using the fundamental theorem of calculus.
Oh, so we are using the absolute value, we just don't need to.
Correct.
That's
Because x squared plus 1 is always positive.
I'm still going to put absolute value.
Okay. We leave out the c because we're finding the definite integral. So we know it's from 0 to 3. And so now, just plug it in. So 1/2. Okay, we can pull that out. So it's natural log of 3 squared plus 1 minus natural log of 0 squared plus 1. It's the fundamental theorem of calculus.
Oh, that's good.
So it's f of b minus f of a. Okay. So what is this? Natural log of 10 minus natural log of 1. And what is the natural log of 1? What? Yeah, you do. 0. So this is really 1/2 the natural log of 10, which, how else could we write this? Ten to the 1/2, which is root 10. Or we could put it into our calculator.
That's cheating. It's a long way.
Then we get 1.151.